Welcome to Holt Geometry. Today we're going to talk about lesson 9-4, the effects of changing your dimension, the side length of something, on both area and perimeter. Big focus on area, but let's look at both. Example 1, let's look at just changing one dimension, base, height, whatever we want. We'll start with doubling the height of a parallelogram. What's that going to do to the area? Well, the way I'd find out is to write down the area formula for a parallelogram. Area equals base times height. The formula for the new parallelogram with double the height will be area equals base times, and you're going to just have to do 2 times the height. That would give you double the height. Now, how would that change the area? Well, I'll take my new formula, base times 2h, and divide it by my old formula, base times height. Well, b over b, whatever that number is, it's going to cancel out and become a 1. H over h will do the same thing, and I'm left with the new area is twice the area of the old one. So notice if I double one dimension, I'm doubling the area. What if I doubled, will this work for any figure? Let's look. What if I multiplied the base length of a triangle by 1/2? So I'm going to cut it in half. My original formula, area equals 1/2 base times height. Well, the new formula then, area equals 1/2, and instead of just writing the base, well, I need half the base, and then the height, of course, is going to remain unchanged. Now, how does that affect the area? Let's put our new formula, 1/2 times 1/2 times base times height, over the old formula, 1/2 base times height. And you can see heights will cancel out, bases will cancel out, 1/2s will cancel out, and I'm left with an area that is 1/2 the size of the old area. So the new area is 1/2 the size of the old area from this formula. What if I change more than one dimension? Look at an example 2. We call that changing dimensions proportionally. And that means whatever we do to one side length, we're going to do to all the dimensions. So if we're going to double the base and the height of a rectangle, what happens to the perimeter and the area? Well, perimeter formula for a rectangle, if you recall, is 2 times the base plus 2 times the height. So my new perimeter, if I double the base and the height, will be 2 times the base plus 2 times the height. Now, how's that going to affect the perimeter? Well, new over old, I've got 2 times 2b plus 2, whoa, that's a height here, plus 2 times 2h. And that's the new perimeter, and it's going to be over the old perimeter, 2 times the base plus 2 times the height. 2 times the base, that's over itself is 1, 2 times the height over itself equals 1, and I'm left with 2 plus 2. The new perimeter is 2 plus 2, 4 times the old perimeter. So notice since we doubled base and height, 2 plus 2 is going to give us 4. What about area? Well, my original area for a rectangle, area equals base times height, and my new area will be area equals 2 times the base times 2 times the height. Again, just put the new formula over the old one, 2 times the base times 2 times the height, over base times height. Notice it doesn't matter what the base and the height actually are, because they're going to cancel out every time when you do this. Base over base is 1, height over height is 1. And the effect on the area, 2 times 2, the new area is 4 times larger than the old area. So again, this formula, it's going to work every time. Write down the original formula, figure out the new one with whatever effect they gave you, cancel out what you can, you'll find your answer. What if we need to go backwards? Okay, let's look at example 3. If the area of a square is tripled, what's going to happen to the side length? We'll start with our original area formula. Area equals the side squared. Now my new area, the area changed. It's 3 times the old area. And the side length changed. It was multiplied by something to get the new side length. So, and we'll let that number be k. So k times some number is the new side length, and that's going to be squared also. Okay? So now how am I going to find this change in the side length? Well, I'm going to have to solve for this k. So my first step, I've got a lot of variables going on. I need to substitute. I know a equals side squared, so I'm just going to substitute side squared in there for area. So I've got 3 times the side squared on this side. And here I'm going to distribute my exponent. Whatever that change was squared times s squared. Okay. Now, again, I need to solve to find k, but I can divide by s squared on both sides, and that'll cancel out. So now I've got 3 equals k squared, and to get k alone, evidently, all I need to do, opposite of squaring, is square rooting. So the square root of 3 equals k. What that tells me is the change in the side length was square root of 3. I multiplied square root of 3 times the original side and got the new side. That's what it's telling me. In summary, anytime we change dimension, the change in the perimeter or circumference, if you're doubling it, it's going to double. If you're tripling one thing, it's going to triple. If you're quadrupling it, it will quadruple. If the change is 2, perimeter or circumference changes 2. Changes 3, perimeter or circumference changes 3. Area, you saw an example too. If you've got 2 dimensions that you're both multiplying, then your change is going to be whatever you're changing by squared. So if I multiplied my dimensions by 3, the area change would be 3 squared, or 9. If I multiplied by 4, the area change would be 4 squared, or 16. And if I multiplied by a half, the area change would be 1/2 squared, which is 1/4. So use these ideas, please. Use your formulas when you do your homework on Lesson 9.5, and show me these steps. Original formula, new formula, and effect. Thanks, and have a great day.